Hello, today I want to share with you some knowledge about performance testing types and specifically we will describe what is load profile, what is the open model and closed model, what is the difference. We will speak about performance testing type like load test, performance test, volume test, spike test, soak test or endurance test, capacity and breaking point test, average load test, and even about smoke test. So let's go, and this video should be short and efficient in scope of understanding theoretical part. So closed model, what it's mean under the term of load profile, we try to hide information how we want to simulate the load to the system, what it will be, amount of virtual users or amount of requests per second. If we're talking about testing any kind of web application like a website, e-commerce application like I don't know, Amazon.com, or it can be something like eBay, etc., or any local platform like iHerb, Rosetka, etc. We're talking about scenarios like end-to-end tests, and we want to simulate the user's behavior in our performance test. In this case, we want to simulate the amount of virtual users what will be execute some scenarios. It can be the same scenario, it can be the different scenario. For example, like classical example, when we have a e-commerce web application to sell the book, for example, and user should open the main page, press login or do not press login. So we have two types of user, anonymous user and register user, and some amount of users will perform login, another amount of users should immediately start to search something, add item to the cart and proceed with checkout, another should just add item to the cart and do not do any kind of checkout activity, and so on. So this is a closed model when we don't want to handle amount of requests per second, we want to handle only amount of virtual users, and under the hood of virtual users we will mean amount of parallel scenarios what should be executed. And here, like, very efficient tool can be JMeter, Load Runner. Definitely you can use for closed model simulation Gatling A and K6 as well, but easily to do it in JMeter due to like record and play functionality and so on. But it's like not so important. We will speak about both in the future, so it's nothing special. And what is the open model? Opposite to the closed model, open model, it's about requests per second. So amount of how many time I hit my endpoint, my REST endpoint into my service, and about of amount of these endpoints under the load, and so on. So when we're talking about load profile, it's about what we will test, how we will test, and what is goal to understand amount of users, what our system can handle it without performance degradation, or understand amount of request per second, operation per second, some kind of throughput in scope of atomic transaction onto the in the backend side, comparing with the closed model. So this is a difference. Yeah, in both we have to understand throughput of the backend, but if we're talking about closed model, we will be user centric, and we will focus it on amount of parallel scenarios what executed, And in the open model, we will be focused on amount of hits for our endpoints. So we will focus it on request per seconds. You have to understand that in case close model, amount of requests per second can be significant, but it will be different endpoints and different services. For example, if you're talking about serverless or microservice architecture, it will be the different services, the different Lambda functions hit by our simulation. Yeah, and it's like very hard to handle it. What service got exact amount of requests per second and understand atomic service performance. It's much more easily to understand whole system performance due to like initial goal of closed model. And opposite, it's about open model. When we're talking focused on request per second, it is much more easier to understand performance of atomic REST API or atomic gRPC or SOAP service, what we want to test from in scope of performance testing. So we will increase amount requests per second till we will saw some performance degradation. Yeah. Okay, and let's speak about performance testing type. So load testing, it's like the same as a performance testing. It is a classical part of performance testing. The load testing is just to saw system under the load. Yeah, so we generate a load and saw how system works. But performance testing, in the same way, it is analysis how currently system work under the performance. And in scope of the performance, we have some kind of the boundary. It is this is boundary defined in non-function requirements, and it's like range until we know that system should handle it this level of load in scope of non-function requirements on, or if we're talking about we go out from non-function requirements, so we make step to bigger load than we mentioned in requirements, then it's some kind of stress tests and combination with capacity test and so on. So we try to find real border of performance for our application. So, but load testing, performance testing, it's the same. It's about how to system work under the load and so on. So stress testing, as I mentioned before, it's high level load with main goal to break the system. Yeah, and it's usually more than value what we have in non-functional requirements. Volume testing, it is performance testing type, but in volume testing we try to generate a load to the system not by amount of request to the system, but by amount of data what should be used in transaction inside of the system. For example, the performance of some e-commerce, yeah, or maybe not e-commerce, like bank software can be different due to size of database, yeah, because the cost in scope of time searching something into the database with size like 20 gigabytes and size 200 gigabytes, it's absolutely different due to complexity, amount of indexes, how what database structure do we use inside, what normalized form we use in our tables, in general what is the database engine, Is it configured and more suitable to read operation or to write operation, or it is balanced, and so on and so on and so on. So volume testing, it's about testing with different size of data. It's not means that, oh, I want to make a volume testing, then I need to use terabytes or petabytes of data. No, it can be like comparing like 100 megabytes and 1 gigabyte, like 200 megabytes and 2 gigabytes. So it can be even simpler with some kind of smallest amount of data, but just to show how they will proceed. Spike testing, it's a type of testing when we generate a lot. After that we have some short period of time when we quickly increase amount of load to the system and return back to previous load level, and after that continue and doing sometime like few times in the row. It's look like some CrossFit training, yeah, or wrestling training. Capacity testing. Capacity testing, it is usually mean test to find saturation point, and saturation point, it is a point in the chart of load testing when we don't see increasing throughput, and throughput, it's amount of transaction what can be handled by our backend server in point of time, yeah. So this is what is a capacity test. And reliability recovery test, definitely it is a test how system recover and the level of stability under the load. Smoke test, it is a some fast load test to understand that main scenarios will works even under the load. Usually it can be generated, it can be performed like, okay, we have a smoke suite of automation tests, let's run the same suite with different users in parallel in multiple times, and okay, 10, 100 virtual users was generated by these scenarios, and we did this test and everything works smoothly, so fine, we are totally on track. Okay, and endurance test or SOAK test, it is test what run it for long period of time to find some kind of memory leaks. In general, any kind of performance test can show the memory leaks. For example, spike test can show memory leaks, stress test and recovery testing also can show it. Endurance tests show how system perform under the load for huge period of time, and it's really necessary for some services, for some 24/7 application like payment transaction, like healthcare services, etc. And let's saw some visualization. So I use JMeter Shaper timer to visualize it, so it's pretty close to real tool experience. And what we have here is visualization for load and performance test. So we have some ramp up period, yeah, so from 0 to 1000 users we increase it in 1 minute, yeah, and after that we handled this load for 14 minutes, and we do ramp down in 2 minutes as well, yeah. So it's some kind of more classical way. And for example 1000, it is a border of non-function requirements, and our goal to analyze the system, how system handled 1000 parallel users or 1000 requests per second, what is more correct due to specific of this shaper time. Go to the next example, and it is a stress test. And stress test, it is a straightforward increasing load to the system in short period of time to find degradation. Currently here we increase amount of requests per second from 1 to 10,000, in 2 minutes, in 120 seconds. Spike test, it is, as I mentioned before, some kind of CrossFit training. Yeah, so we have a ramp up period. We increase load to the system up to 2000 requests per second. After that, we do ramp down to 500 requests per second, and we handled 500 requests per second for some period of time, and after that do it again, and again. And it is needed to understand that, for example, we test Java application, we increase load to the system, and JVM use more memory to handle multiple instances of object what was created in heap. Yeah, it's some like a part of the virtual memory system in Java virtual machine. So heap size was increased immediately, and we saw how used RAM was cleaned and returned to the currently hardware. Yeah, so JVM stopped use RAM and returned to the previous RAM usages. It's some kind of example. Or for example, we can find that CPU, yeah, like the practical example, we did this kind of tests for microservice system, and we saw that some system after a few spikes do not return to the Kubernetes cluster CPU resources and use like all possible, currently use limit level even without load. Yeah. So we did some experiment and found that, yeah, we have some kind of strange behavior, that CPU utilization increased after first spike, and it's not decreased after load ramp down. Yeah, so it's usable for CPU, for RAM utilization, etc. So okay, what is the spike test is? Now, next, it is SOAK or endurance test. Yeah, so it's the same. What it means that we have a ramp up and we have very long period of time, so like 5 hours under the load. Yeah, so the test run 5 hours and the system under the load like 5 hours, and we understand, okay, we can handle this load for 5 hours or even more. Then we can predict, and we can mention that our software is stable 24/7 and we able to handle this load for long period of time. It's very valuable. Capacity test and breaking point test. So what it means? The capacity test, as I mentioned before, it's to find the saturation point. Saturation point, it's a point on the chart when our positive processing speed of our backend stop increased. Yeah, because usually we increase amount of requests per second and throughput increase as well. This it means that how many times we ask something for our system, it means the same amount of response we got in the same period of time. Yeah, and when we saw that amount of answers stop be equal to amount of requests, it means that we found saturation point, and we saw in the future that after that point, after some increasing of load and some time, we saw performance degradation. Yeah, so it will mean that we found saturation point, and after this point we should expect performance degradation. And breaking point is increased cloud until we saw not only performance degradation, but also we can crash the system, and it combination with stress test as well. The difference, stress test can be more faster in scope of the increased load to the system, yeah, period of ramp up, and breaking point can be more smoothly. And average test, it's currently like just the same as the load test, but with average level of load. Currently here I use 1000 requests per second, but for example it can be like 500 requests per second if 1000 is final boundary of the NFR. But if NFR, for example, 2000 requests per second, then 1000 is pretty fine. And smoke test, it's the same. So we have some small amount of load to the system for short period of time, just to see that we don't have any kind of significant performance degradation. And this is the end. Thank you so much for your attention and have a wonderful day.